Peter Bildgaard, running down the stairs. And as a student in the Environmental Management and Sustainability program, continuing from this third semester project on ecosystem services, evaluation of ecosystem services for climate action, a fairly interesting novel approach here in northern Denmark, and will now present findings so far. Go ahead.
Yeah. So, yes, ecosystem services, I'll try to see if I can explain to you how that could be integrated into climate actions. It will be a combination of what I've already found out in my third semester and a status of where I am right now. So, just briefly a bit about myself. I have a bachelor degree here at Aalborg University in urban energy and environmental planning. And up there is the 3 previous projects that I've done on the master program. And I won't stand here and talk about the findings from those projects, but just briefly talk about what the main topics was. The first one I did was about biodiversity conservation, where you engage stakeholders from the private sector in what could be termed as kind of an art cooperation. And then on the second semester, or the 8th, I looked at the cross-border collaboration on climate change adaptation in London. And those 2 projects was actually the foundation for what I tried to do in my third semester project and my master thesis. I tried to combine these topics. Well, biodiversity I zoomed out a bit and talk about ecosystems instead. I look at a private initiative in climate change adaptation. Normally we expect our government to do something, but here we have a private initiative. Just a bit about the case area where it's located. Right now we're sitting in here in the center of Aalborg, as many of you already know. The case area is out east, in the eastern part of Aalborg.
Use the pointer.
Yeah, you can read it up there. So. The frame here, that is what is considered as Aalborg East. And here we have Kildeparken, which is my case area, owned by the housing association called Himmerland Housing Association. Also out here we have Aalborg University campus. Yeah, that was just to show you a map of where we are for those of you who are not familiar with Aalborg. So, in 2011, the Housing Association produced a master plan on how to redevelop the whole area. The area is approximately 54 hectares. It has about 2,500 residents and approximately 1,100 housing units. And it was built in the 1970s, and it hasn't really experienced any major renovation or redevelopment since the 1970s. So it's an area that is starting to be worn down, and the buildings need for a renovation. So a part of this master plan, which is the one that I have focused on, is how to handle rainwater on the property with a system called sustainable urban drainage system. I will just very briefly explain the concept of a sustainable urban drainage system for you who do not know that. And I'm not sure if you can see it, but the drawing is to illustrate a bit how this system are to be implemented. It's about collecting rainwater from rooftops and from parking lots and from roads and pathways, and collect it in small channels and then have it in larger ponds or lakes. So, yeah. And what initiated my study was that the housing association were not able to finance this system. The whole redevelopment project project has the cost of approximately 1 billion Danish kroners. And this system is just a very small part of this redevelopment project. But the funds that are funding the rest of the project will not fund this part of the project. And the housing association have called upon the municipality for help, but they will not support. They have called upon the water utility company for help, but they will not support. So they have a problem of how to finance this system. So that was what triggered me. And so I have looked at this very specific thing. And I had to find an alternative way to finance the system. And by looking at a sustainable urban drainage system, it can easily be compared to how an ecosystem is functioning. It has some of the same services, and I will get back to that also, ecosystem services. So, but the initiating problem statement was that to what extent could this concept of paying for ecosystem services be integrated, help to finance the implementation of this system in Killeparken. And this overall problem statement was divided into these two projects, one that I have already made, where I identified these services that this system could provide, and also the potential stakeholders and potential buyers of these services. And what I'm currently doing on the 10th semester, or the master thesis, is to try to determine a value of these services, which is actually the difficult part, because these are services that we do not normally value, put a financial value on or economical value on. And then also to go out and talk to these different potential buyers and see, are you really interested in this project? Do you know of this project? And if you are interested, could you be willing to pay for this project? Which is perhaps the most interesting thing about it. But just very, very briefly, something about sustainable urban drainage systems. It can be considered as an alternative to conventional sewer systems, which is in pipes underground. Now you have the opportunity to have the rainwater on overground. And there are these 5 elements in such a system, which you have to have some sort of detention or delay basins or ponds. It could look like the picture up there, which is from Augustenborg, an area in Sweden, Malmö, Sweden, where you can store the water when it's collected from the rooftops. You can have some sort of infiltration, where you have the water infiltrating to the underground. And evaporation, you have some sort of natural evaporation from the ponds. And you need to transport the water from the parking lots, the roads, the pathways, the roofs, and it could look something like that, or you can do it in many other ways. And then this water needs to be cleaned sometime, because the roads are polluted and the roofs have pollutants. So that's just to put some pictures on it, how it can look. And then also briefly about the concept of payment for ecosystem services. And I guess most of us know what an ecosystem is. I just put a definition up there, or a formulation that was used by Robert Costanza. And I thought that it was quite good, saying what an ecosystem is. I won't stand here and read it, but and then just a few pictures of some of the largest ecosystems that we have here on Earth: the Amazonian rainforest and the Great Barrier Reef. But these systems can provide a lot of services for us human beings, that we all, so there are these 4 categories of services, and the most important one is perhaps the supporting services, because that is the foundation for all the other services. That is, for instance, habitat, creation of habitats for biodiversity. It's restoring nutrient cycles in balance, and it's for making new soil, and so on. We have some provisioning services, which are some of the services that already have some sort of value to us human, monetary value to us humans. We have food production, and we have wood production and fiber and so on. And then we have some regulating services, which is climate regulation, flood regulation, and so on. But these are the type of services that we are not paying for. They're just out there for our use. And then also the cultural services, aesthetic impacts of these ecosystems. And so, I just put in two examples of cases where there have been paid for ecosystem services. And one of them is from France, Vitel, the mineral water company. They experienced that their water resources were starting to be polluted by farmers by using fertilizer, and their business was in danger. So they went out to these farmers, made an agreement with them, saying that you need to change your cultivation practices, and we will pay you for that. So the 25 billion euros was the investment for the first 7 years, but it turned out to be a great investment because they could still produce mineral water. So the investment was far smaller than the benefits. Yeah, they secured the water resource, and that's just one example where you can say a buyer are contacting or making contact to a seller. And then another example is the protection of rainforests in Ecuador. In Ecuador, they have a lot of oil resources in the underground where the surface is covered by rainforest. And the Ecuadorian government said that if you need us to not use these oil resources, you have to pay us $3.6 billion US. That was the estimated value of not using this oil. And they made this suggestion in the United Nations, and several countries have already said that they would like to support this initiative, and I just put Germany up there because they're paying quite a lot amount of money for this initiative in order to save this very large area of rainforest. So there was just a few examples of that. So back to my work with my case. I used these 4 categories of services. I looked at the system that they plan to implement in this area, and I looked at how you would normally do it with the conventional sewers. And as you can see, there is quite a lot of extra services provided by this sustainable urban drainage system compared to the conventional sewer system, which is actually only about collecting rainwater, and if they are in the right dimensions, you can avoid a flood of lower land. Yeah, the system has the ability to lower the pressure on the natural recipient of this rainwater, which is highly overloaded and polluted. So it could help this water course as it is. It can create a green space in this urban area, which is, you couldn't see from the map, but it's actually lacking some sort of a green area in Aalborg East. So that could be helped to create that. It will have the regulating services, also like the conventional sewer system, avoid a flood. And it will have some sort of local climate regulation. It is scientifically proved that a green area in an urban area are able to lower the temperature by several degrees on hot summer days. So perhaps that could also help with that. And there are some cultural services, and most of them evolve around recreational use of this system. So I use these services to try to identify some potential buyers of these services, someone who could be willing to perhaps pay for it and by that support the system financially. And well, out on your right is the motivation, or what also the services out there. But what I found is that there is a broad range of stakeholders that could potentially have an interest in this project. If you haven't used these services, you probably would only have ended up with Gildeparken and the residents out there as the main stakeholders of this system. But by using these services, you actually end up with a whole range of different stakeholders. And yeah, you can read them for yourself. And then the next big step for me, and what I'm doing right now, is this table kind of illustrates my current work. How to put a value on these different services. And there are these three types of valuations: financial value, or the value of an alternative, and the economic value. And the most interesting one, and perhaps also the most difficult one, is to try to put an economical value on this system, which is the value of recreational value, and also living close to a green area, for instance. But I put some numbers out there, and the financial value is perhaps the easiest one, because that's just the implementation cost of this system. And there have been estimated some numbers out there, 20.7 million Danish kroner, and an annual maintenance cost of 150,000 Danish kroner. Perhaps the interesting thing is to compare the renovation of the existing sewer system. That cost is far less than what it costs to implement this system. But that is where the economical values are very important, because these have to outweigh the cost difference, so that it's actually good to build this system, and you get so much more out of it.
Can I just ask a question here? We got that slide.
Yeah.
69,000 Danish kroner on the insurance costs.
Yeah.
What is that? That's not per person. Is that just?
That's per insurance claim. There were approximately 90,000 insurance claims after the.
Including mine, yeah.
Yeah, and it was estimated to 6.45 billion or something like that.
So I mean, how many homes or apartments or whatever are there in this property that you're looking at?
Well, in the property, in the case area, there are these 1,100 housing units.
So you would multiply 1,100 by 69,000?
No, because not all of them are in danger of a flood. That's actually only the lower part of the area, and there's not really that many apartments.
But do they have storage in the basement? Because that's what happened to, like, our building. Everybody, including myself, had the items stored in basement storage, and all that got ruined. So it wasn't, I mean, that's, so you could actually, if they do have that, multiply that. You would jack up your price a lot there.
Yeah,
Make a better business case.
It can be used as a rough estimate of what the possibility, or what the cost could potentially be if the area was flooded. And also the area southeast of this case area, it has a lot of single house homes, and these are also in danger of a flood.
But Peter, one of the things that's important is that the area itself is not problem. It's the lower lying areas in the business parks, university area, new hospital area. So you may want to look at what's the cost of climate securing your building vis-a-vis we building this sustainable urban drainage system so the water never reaches you. That's one of the discussions we need to have, right? That's avoided costs basically that we're talking about.
And then the other thing is the 2 to 10% increase in property value. So there are 1,100 units there, and they increased by 2% each. And then you multiply that by 1,100. I don't know what the price of one of those apartments, for instance, is, but then you also might get your business case.
I should just put perhaps a few comments on those percentage. It's a new Danish study just published that shows that living within 500 meters of a green area, you can potentially increase your property value with up to 10%. And if you live 500 to 1 kilometers away, it's up to 2%. Yeah. But this table, I'm working on it, and I will perhaps fill it out as we're going. So just a few comments on my expected outcome of this research. I'm working on making some interviews with these different potential buyers. And if I put on my optimistic eyes, I could hope that a few of them could find this interesting and would be willing to invest in such a project. But if I have to be realistic, I expect to be met with more like a wonder of why are we to pay for this system, because it's actually not on our property. It's not us who want to build this system. And if that is the case, I just hope that there could be some learning lessons in my study, and of course for the housing association, which is the case area, they could learn that the system that they're building is not just a water handling system on their own property, it's so much more than that. And also I believe that Aalborg municipality could learn a lot from this, because they are some of the larger benefiter from a system like this, and it can help them in so many ways. So by investing a very small amount of money in such a system, they could have a payback far greater than what they invested. And just a bit about how I plan to make sure that people will see my research or my study is that I've made a summary. I've made one from the 9th semester, and I plan to do it for the 10th semester. And I've sent it to the housing association so they can see what I'm doing, and also the municipality will have the opportunity to see it. So I just hope that they could have some inspiration perhaps for future discussions. And just some general reflections, or perhaps some key messages from this study, is that the housing associations are, from a Danish context, is a very important player in climate change adaptation, because they own very large areas and they have a large number of citizens living in their areas. So you can easily communicate to a lot of people, and you can have some actions taken in large areas. So that's a good place to start when doing climate change adaptation. I wrote think out of the box is related to the system. If you just consider the system as a water handling system, that is what you get. You get a system that will handle the water. But if you, as I have done, look at it like a tiny ecosystem, you can have so much more added services to such a system. So it's so much more than just water handling. And then finally, one of the things that I find very interesting is to engage what I termed as the not so obvious stakeholders. Somebody sitting out there and could never imagine themselves being involved in such a project, but actually they could benefit from it. So it's very important to get these not so obvious stakeholders involved in this. And for the specific case out in Aalborg and Kildeparken, it could definitely help to create some sort of ownership out there, which is lacking, and also try to create a stronger community, which is perhaps also not existing out there. So, yeah, that was just.
Thank you, Peter. Then just before lunch, I know, but are there any questions, Peter? Yes, Pete?
Yes. So thank you very much for your presentation. It was really enjoyable. I was really curious to know how do you value the services? Like in the slide 12, you showed like some monetization. What is the method behind? I mean, how do you come up with a fee?
Yeah, I have to use existing literature to do that. So that's what I'm doing. Or perhaps, if I have the time, I could go out and do a survey and ask people, what is this, what kind of a value do a green park have for you? And then they could put a monetary value on it.
Okay.
But I have, with my time constraints, I have to use existing literature, which there are a great number of literature on this topic.
So surveys on what people, how people evaluate this.
Yeah, exactly. So, and I use this Danish study and how much the property value could increase. So,
When you're talking about a water handling system, are you just talking about putting the water in the lake when it's raining, or have you thought about other uses for the water? You could actually maybe purify it, use it for drinking water, use it for toilets, something to integrate it much more?
That's part of the master plan. I didn't go at all into deep with the master plan, but there's quite a comprehensive master plan of this area, and they have an idea of how the system should look. And it's not only the idea to collect the water when it rains, but to have a permanent water table in these ponds, so it can be enjoyed all the time. And of course, they will also try to build some water playgrounds where the water will be circulated and can be used for children and playing.
These green areas in the city that can reduce the temperature, how do you define it? Green grass, forest?
That has to be park areas. With the study that I've read was that it has to be park areas with trees, and that's just the green field. That probably won't do that much. So,
Thanks very much. And, thanks for